In Unit 2, we're talking about how to measure the distribution of resources across an economy. If you remember from Unit 1, we talked about how to measure all of the resources in an economy in GDP. But one of the limitations of GDP is that it doesn't show us how those resources are distributed and whether it's equitable, that everyone has an equal share, or whether some people have a lot and some people have a little. And so in this unit, we're going to talk about ways that we talk about the distribution of resources throughout an economy, and particularly two ways that we measure this. And that's this video is going to cover those two ways. So the first one is a graphical measure that we call the Lorenz curve. It's going to be a graphical representation of the distribution of resources throughout an economy. And then the second one is a number. It's a statistic called the Gini coefficient. Is also going to tell us something about how that distribution is and whether it trends more towards equality or inequality. Okay, so let's jump into an example to see how both of these two are created. In this example, we're going to assume that there are 500 people in this economy. Okay, so we've got all of their individual incomes that they make for all 500 people here. Okay, so if we want to understand how equitably these resources are distributed throughout the economy, one way we could do that is by measuring the percent of the total resources that each percentile in the economy has. So if you think about a perfectly equal society, the bottom 10% should have 10% of all of the wealth. And the next 10% should also have 10% of the wealth. And all the way up to the top 10%, which should also just have 10% of the wealth. In an inequitable society, you might imagine that the bottom 10% only have 1% of all the wealth, whereas the top 10% have more like 40% of the wealth. And so what we're going to do in measuring a Lorenz curve is we're going to look at each of the percentiles of the population and what share of the total wealth they have. Okay, so for this example, we're going to use deciles, which means every 10%, 10th percentile of the population. So to do this, we're going to start at 0, and then we're going to go all the way up in increments of 10. So we're going to say 10%, 20%, 30%, all the way up to 100%. Now note that I have these in percentage form. This is important. If it's not in percentage form, these needs to be 0.1, 0.2, 0.3. Okay, that's important for our calculation. To get the decile amounts, we use the percentile function. Okay, so if we equal percentile, okay, we're going to want to use either the INC or just the regular percentile. Either one of those is going to give us the right answer here. So percentile, so if we click here, it's going to first ask us for the array, which is just the data we want to look at. So this is, we select all 500 incomes here, okay, comma. And then the second thing it wants from us is what it calls K. That's just what percentile we want it to return. So here we just want the 10th percentile. Now, one thing we need to do real quick is we need to lock in the data, because for all of these, we're going to want to click and drag this. So if we lock it in, then we can drag this down, and it's going to tell us all of the different percentiles. Okay, so it returns this amount of $19,998. So this says that if you make that or less, you're in the bottom 10th percentile of incomes in this economy. Okay, so we're going to want to get that number for all of these. So we'll just click and drag this down. Okay, so here you can see all of the different amounts that represent the different deciles throughout the economy. So if you make more than 133,000 a year, then you're in the top 10%. So now what we want to do is for each of these deciles, we want to understand what percent of the total wealth in this economy does each of these deciles have. Okay, so the first thing we need to do is we need to calculate the cumulative share, meaning what is the total amount of money that everybody in the bottom 10th percentile has. Okay, so in order to do that, we're going to use sum if. Okay, so it's going to sum up incomes if, and what we want to do is we want to add everything up if the income is less than this amount right here. So the first thing it asks us for is the range. So this is this amount here. All of these, select all 500 incomes again, okay? The second thing it wants is the criteria, saying sum if what. So we want to sum if it's less than or equal to this amount here. Now, the notation for this is kind of odd, okay? So we put this in parentheses. We say less than or equal to, and we close the parentheses, and then you put an and sign. This is one of the worst notations in Excel. I don't know why they have it this way, but that's how it is. And then we click this cell here. So we say we want it to sum up all the incomes if it's less than or equal to this amount in F3. Okay? And again, the last thing we need to do here is we need to lock in the criteria range and hit enter. Okay, so this is how much, if you take everybody who lands in this bottom 10%, this is the total amount that all of them have. Okay, so now we want to know what that is for all of these. So as we drag this down, again, it represents the total amount of money that everyone in the bottom 20% has. Now, one thing to keep in mind is that the bottom 20% includes everyone who is also in the bottom 10%. So this is cumulative. It's adding up more and more people as we go. Okay? So as we continue to drag this down all of the way here, what this is showing is the cumulative share that they hold for each of those 10%. Okay. Now, if we've done this correctly, this 100%, because this is a cumulative share, this should be equal to the total in all of the economy. So one way to check that is we can just sum all of these incomes together and see what it gives us. Okay, so we can see that that's equal here. So this worked. This is showing the total amount that each of these deciles have. Okay, so now again, what we want to do is we want to understand what percent of the total income each decile has. So what we're going to do in terms of understanding that percent is we're going to take the cumulative share and divide it by the total amount in the whole economy. Again, this is telling us out of all the money in this economy, what percent of those resources does the bottom 10% have? So we're going to lock in that denominator so that we can drag it down and hit enter. Okay, now this is really interesting, right? So if it was perfectly equal distribution in this economy, the bottom 10% should have 10% of the wealth. But they actually only have 2% here. Okay, so this is telling us something about the distribution of the wealth. Bottom 10% of people only have 2% of the wealth. Okay, as we drag this down, you can see that this is going to do the same. So the bottom 20% have 6%. The bottom 30% have 10%. Okay, and we can keep going all the way down to here. Now we can see that this is working, right? Because once you get to the top earners, that all of the wealth is accounted for. But even up until the bottom 90% only have 67% of the wealth. So that's telling us that this top 10%, going from 90 to 100%, the earners who are in that top 10%, they actually have 33% of the wealth in this case. Okay, so again, that tells us something about the distribution here, that the bottom 10% have 2% and the top 10% have 33%. Okay, so now we're going to try and look at this graphically to try and compare. Now remember, we're going to create here just like this line of perfect equality. So just as a point of comparison. So if it was perfectly equal, the bottom 10% would have 10%, the bottom 20% would have 20% of the wealth, right? So we're going to continue that all the way to 100. We're going to put zeros here too, just to make it complete graphically. Okay. So here's what perfect equality would look like. Their shares would be perfectly equal across all the deciles. This is what it actually looks like. Okay, so now what we want to do is we want to graph this. So what we need to do is we need to select the deciles, the actual distribution, and the line of perfect equality. Now, how you select that, it's going to be different on your computers. Sometimes it might be easier to just hide these two columns and just select these. If you have a Mac, you can use the command function to select these three at the same time. Okay, we're now going to go insert, and we're going to want to do a scatter plot. Okay, if you choose a line graph, this is not going to work. Okay, you have to use a scatter with lines. Okay, that's the only way that these are going to get kind of on the right scale and have the axes the right way. You want to choose scatter with straight lines. You can do it with markers if you want, or just with straight lines. Okay, when I select this here we go. Here's our Lorenz curve. Okay, so the red line shows what perfect equality would look like. And the blue line is showing where they're actually at. So you can see where this dips down all the way through here. This is showing that all of these individuals, these categories, have less than their fair share. And then as we talked about, right as you hit about 90%, you see the steep incline that shows that all of the catching up to 100% is happening in this last 10%. Okay, so again, we'll talk about more how to interpret this in class, but this gives you an idea for how we can create a Lorenz curve to show us a comparison of line of perfect equality with the distribution that is actually going on in the economy. Okay, the second tool that we have for measuring the distribution of resources across the economy is the Gini coefficient. We'll talk in class more specifically about how this is actually calculated. It's very complex, and so I'm not going to require you to do it by hand. Anytime I ask you to calculate the Gini coefficient, I'm going to ask you to use this Gini calculator here. Okay, so we'll jump over to this calculator. The way that this works is if for this Gini calculator is you have to enter all of the incomes in the economy. Okay, and you need to separate them by commas. So we have over here all of the incomes in this economy. What we need to do is separate these all by commas and list them all in this calculator. Now that looks really daunting and tedious to do this 500 times, and so I'm going to show you a very quick way to do this. Okay, over here, if we use the text join function, this allows us, it's literally going to join the text in cells, and we can pick what we want to separate each of those when it joins them. Okay, that's called the delimiter. So here we want to separate all of these by a comma. So I'm going to use quotations and a comma that says join all of these but separate them with a comma. And then it's going to ask us ignore empty. We're going to put true. And then it wants the range of things that it wants us to join. So now I'm going to select all of the incomes here. Okay. So now you can see what it did here. So it's put all of these together, and I mean, it goes on forever and ever, right? But it's joined in one place, all of the incomes separated, each of them by a comma. So now we can just copy this, and we can jump back over to the Gini coefficient calculator and plug this in here. You can see that it entered all of these incomes in here separated by commas, and we can hit calculate. Okay, so here is our Gini coefficient. And we're going to, and it also produces a less helpful version of the Lorenz curve here, okay? But the Gini coefficient here, remember, we'll talk more about this in class, but the closer it goes to 0 is perfect equality. The closer it is to 1 shows more perfect inequality. Okay, so it's fairly high in this case. It's almost halfway there, right? It's trending probably more towards equitable, but it's certainly not anywhere close to 0, which would be perfect equality. Okay, there you have it. 2 ways of measuring the distribution of resources across an economy, both the Lorenz curve and the Gini coefficient. Now, if these still feel a little confusing to you, that's okay. We're going to cover these. We're going to talk about them more in class. The purpose of this video is more just the technical side of how to calculate it, so you can come back to and refer to this. So if you still have questions about what it is we're actually measuring, how to interpret it, all of these things we're going to talk about in class. But hopefully this is helpful in giving you an understanding of how we're going to calculate both of these things. See you soon in class.